This call is now being recorded.
Okay, so contents of fifth module. It's actually രണ്ട് പാർട്ടായിട്ടുള്ളത്. Okay, first part dealing with the power amplifiers, and second part is voltage regulators, or specifically we can say linear regulated power supplies. Okay, so ഇതാണ് fifth module contents എന്ന് പറയുന്നത്. So രണ്ട് പാർട്ടായിട്ട് വരുന്നുണ്ട്. ഫസ്റ്റ് പവർ ആംപ്ലിഫയർ, അതിൽ ഡിഫറെന്റ് ടൈപ്സ് ഓഫ് പവർ ആംപ്ലിഫയേഴ്സ്, അതിന്റെ അനാലിസിസ്. Then second part voltage regulators, അതിന്റെ different configurations, അതുപോലെ protection techniques ആണ്. Okay, so first we can see power amplifiers. That is first part, fifth module ആണ്. Next last module ആണ് module 5 power amplifiers. So what is a power amplifier? നമ്മൾ ആംപ്ലിഫയേഴ്സ് പറഞ്ഞ കേസിൽ ഫസ്റ്റ് ക്ലാസിഫിക്കേഷൻ ഓഫ് ആംപ്ലിഫയേഴ്സ് പറയുമ്പോൾ among that one category is that voltage amplifiers and power amplifier. One classification was like that. Okay, so far we have discussed about voltage amplifiers, voltage gain, voltage gain. So we have output voltage by input voltage and how much voltage gain we can obtain. Like that we are dealing with the voltage gains, or we can say voltage amplifier or small signal amplifier that we have discussed so far. Now coming to the power amplifier. So what is, first of all, what is the power amplifier and what are the difference between this voltage amplifier and power amplifier, that we are going to discuss first. So we can say a power amplifier is an amplifier which is capable of providing a large amount of power to the load. Load means loads such as motor, loudspeaker, etc. For example, you are familiar with the public addressing system, right? We have a microphone first to convert the sound wave into electrical waveform. Then you will be having a different multi-stage amplifier configurations in order to amplify our signal. And finally, at the final stage, actually we require high power. By amplifier we can obtain high voltage gain. That is, നമ്മൾ യൂസ് ചെയ്ത കോംപ്ലിമെന്ററി കോൺഫിഗറേഷൻ ഒക്കെ വെക്കുകയാണെങ്കിൽ we can obtain high voltage gain. So in order to obtain high power gain at the last stage, in order to get this very large power, okay, so this loudspeaker, motor, the devices like this require a very large power. So in order to provide that very large amount of power, we require a power amplifier at the output stage. That is, before connecting to the load, we require a power amplifier. Okay, so in practical applications, a large amount of power is required in many devices. So we are using a power amplifier. You can say a power amplifier is capable of providing a large amount of power to the load. Okay, so actually in voltage amplifier we can say it amplifies the voltage and we are calculating voltage gain. Here actually we are not amplifying the power. Okay, here we are not amplifying the power, but instead of that, this amplifier takes power from DC power supply and converts it into useful AC signal power. Okay, നിങ്ങൾ ഇതിന്റെ ഡിഫറൻസ് ചോദിക്കുമ്പോൾ വോൾട്ടേജ് ആംപ്ലിഫയർ ആംപ്ലിഫൈസ് വോൾട്ടേജ്, പവർ ആംപ്ലിഫയർ ആംപ്ലിഫൈസ് പവർ എന്ന് പറയാൻ പാടില്ല. It actually does not amplifies power. It actually amplifies voltage itself, but along with that, it amplifies current also. Okay, as you know, our power is equal to voltage into current, right? V into I. So if you are increasing voltage gain and current gain, or if you are amplifying voltage and current, both voltage and current, you will obtain high power at the output. Okay, or we can say simply, this power amplifier takes power from DC power supply and converts it into useful AC signal power. Okay, actually there energy conversion process that is taken place here. That is, it takes power from DC power supply and converts into useful AC signal power at the output. That is the function of power amplifier. These power amplifiers are also known as large signal amplifier. The voltage amplifier, we are calling it as small signal amplifier. Here, power amplifier, we can say it is large signal amplifier. Okay. Now, we can specifically see what are the difference between this voltage and power amplifiers. So, comparison of this voltage and power amplifier. First one is the voltage amplifier. The transistors used has a large current gain beta is equal to 100. Okay, so in voltage amplifier, we are using the transistors like VC107. Okay, normal transistors are used. The current gain will be large, that is beta will be equal to 100. Then, whereas the transistor used in power amplifier, actually power amplifier configuration എന്ന് പറഞ്ഞാൽ നമ്മൾ നേരത്തെ യൂസ് ചെയ്യുന്ന കോമൺ കോൺഫിഗറേഷൻ ഒക്കെ തന്നെയാണ്. നേരത്തെ യൂസ് ചെയ്ത കോൺഫിഗറേഷൻ ഒക്കെ തന്നെ യൂസ് ചെയ്യുന്നത് ആ ട്രാൻസിസ്റ്റർ റീപ്ലേസ് ചെയ്യും. That is the one difference. We are replacing the transistor with a power transistor. We are not using normal transistors for power amplifiers. We are replacing normal transistors with power transistors. Okay, and the difference is the transistor used for voltage amplifier will be having large current gain beta is equal to 100, and for power amplifier this current gain will be very low, that is 20 to 50. Okay, and the second one is input resistance of the transistor is low compared to output resistance. That is that for the transistor used in voltage amplifier, input resistance will be low compared to output resistance. That is, output resistance will be high. In case of power amplifier, input resistance is very large compared to output resistance. Okay. Then next difference is physical size of transistor. While we are taking two transistors, and you this voltage amplifier, transistor used for voltage amplification is very small in size. And you already conducted down DC107. Okay, that will be very small in size. Compared to that, this power amplifier transistor, or we can say power transistor, will be larger in size. The reason is actually our voltage amplifier or the transistor used for voltage amplifier will consumes less power. Okay, for these power transistors it consumes more power. That means there will be heat dissipation. Okay, so more heat will be generated from the power transistor. So in an electronic device heat that will get damaged. Okay, so in order to avoid that, a heat sinking mechanism, that is, in order to remove the heat generated, we need a heat sink arrangement for the power transistor. So we are accommodated with that heat sink arrangement so that the size of the transistor will be large compared to that transistor used for voltage amplifier. It's like that is, the heat generation will be more in the case of power transistors compared to the normal transistor. So that generated heat may damage the component, so that we have to dissipate the heat. So in order to dissipate the heat, we require some heat sink, some metallic arrangement to absorb the heat. So by that our transistor size will be large compared to normal transistor. Okay, and next thing is, we are normal voltage amplifier, we are using RC couple for interstage connection. That is, in multi-stage amplification we are using RC coupling. Here we are using transformer coupling for multi-stage connection. Okay, so these are the major differences between voltage amplifiers and current amplifiers. Your point on we are using normal amplifiers, normal amplifier configurations for this. One difference is we are replacing the transistor with the power transistor. And that properties of transistors is actually the difference between this voltage amplifier and the power amplifier. And the coupling mechanism, that also varies. Okay. Now, that is the introduction. One more thing, that heat dissipation. Okay, less heat dissipation does not require any cooling mechanism. That is in the case of normal transistor. But for power amplifier, power transistor, high heat dissipation and requires cooling mechanism. Actually, a cooling mechanism incorporated in that size become large. Okay, so that are the difference between normal voltage and power amplifier. So one more thing, your point on it does not amplify the power, but it converts the DC power from it draws power from DC supply and given to the AC output. Okay, the power conversion, more power provided. Okay, that is the power amplifier. Now, our first topic is classification of power amplifier. Okay, classification of power amplifier. Actually, we can classify power amplifier according to the percent of time the output transistors are conducting. That is, conducting means transistor can be become on or off during the operation, right? So according to our biasing points, we can, or according to our Q point, our transistor may on or off corresponding to the Q point, that is point of operation. Okay, so here we can classify our power amplifiers according to the percent of time the output transistors are conducting. That is, if you are applying an input sinusoidal signal, okay, if you are applying an input sinusoidal signal, if it is conducting for complete cycle or less than one complete cycle, like that, a percentage of time of conducting. Depending upon that, we can classify the power amplifier. അപ്പോൾ നമുക്ക് ഡീറ്റെയിൽ ആയിട്ട് മനസ്സിലാവും എന്തൊക്കെയാണെന്ന് പറയുമ്പോൾ. അപ്പോൾ നിങ്ങൾ ഈ ഒരു കാര്യം ഉറപ്പാ, criteria classification for the power amplifier is according to the percent of time of the conduction time, percent of conduction time of output transistors. Okay, so according to that, we have different types of power amplifiers: class A, class B, class AB, class C, class D. Like this, we can classify. Okay, so power amplifier categories, different types of power amplifiers. Classification of power amplifiers. Power amplifiers are classified as class A, class B, class AB, class C, and class D. Different types of classifications are there. And digital application wearing class S of Intel. So in our syllabus, we have to deal with class A, class B, and class AB only. First three classes are focus. So before going to the details of each type of power amplifier, we can see how this classification is done. Class A, class B, just details. Okay, so first of all, class A power amplifier. Okay, so we have already told it is classified according to the conduction time. Okay, so here we can say degree of input signal. Okay, full 360-degree of input signal. That is, if you are applying an input signal like this. Okay, actually output ആണ് കാണിച്ചേക്കുന്നത്. So ഇതുപോലെ input signal apply ചെയ്ത് കഴിഞ്ഞാൽ for the full 360-degree of input, that is, or we can say for the full cycle of input signal. Okay, if you are applying an input signal like this for the full cycle of input signal, that is the we can say pi to pi, or we can say 360-degree. Okay, that is the full cycle. So we can say the conduction angle of class A power amplifier is 360-degree, or we can say the amplifier conducts through the full 360-degree of input. Okay, so if you are applying an input like this, you will get the complete cycle at the output. That is the class A power amplifier. Okay, so in order to get this output, what we have to do is we are operating our operating point, that is Q point, is set near to the middle of the load line. That is our operating point. Okay, so we have to set our Q point. Okay, we have to set our Q point at the middle of the load line. If you have set our Q point to the middle of the load line, the conduction angle will be 360 degree. That means the complete input signal will get at the output. Or we can say the amplifier conducts through the full 360 degree of input. Okay. So simply നിങ്ങൾ ആ ക്ലാസിഫിക്കേഷൻ ഇപ്പം ഇത്രയും മാത്രം നോക്ക്. നമ്മൾ ഇതിന്റെ ഡീറ്റെയിൽ ആയിട്ട് അത് എങ്ങനെയാണ് കിട്ടുന്നുള്ള കാര്യങ്ങളും ബാക്കി അതിന്റെ പെർഫോമൻസും ഒക്കെ ഡിസ്കസ് ചെയ്യാം. Okay. And next is class B power amplifier. In class B power amplifier, the amplifier conducts through 180 degree of the input. That means if you are applying an input signal, input sinusoidal signal like this, that is with the time period 2π. Okay. Input signal like this, it will conduct through 180 degree of the input. That is only this pi. Okay. So this only you will get the output. That is why we are calling it as it will conducting for 180 degree of input signal, or conduction angle of this class B power amplifier is 180 degree. Okay. So it will conduct for 1/2 cycle only. ഓക്കെ, നമുക്ക് അതിന്റെ വർക്കിംഗും കാര്യങ്ങളും പറയുമ്പോൾ അത് അതിനെ കൊണ്ടുണ്ടാവുന്ന എന്തുകൊണ്ടാണ് അങ്ങനെ ചെയ്യുന്നത്, അതിനെ കൊണ്ടുണ്ടാവുന്ന അഡ്വാൻറ്റേജും ഡിസഡ്വാൻറ്റേജും ഒക്കെ ഡിസ്കസ് ചെയ്യാം. ഓക്കെ, ഇപ്പൊ നിങ്ങൾ ആ ക്ലാസിഫിക്കേഷൻ മാത്രം ഒന്ന് മനസ്സിലാക്കുക. അക്കോർഡിംഗ് ടു ദ കണ്ടക്ഷൻ ആംഗിൾ വി ആർ ക്ലാസിഫൈങ് പവർ ആംപ്ലിഫയേഴ്സ്. ഇൻ ക്ലാസ് എ ആംപ്ലിഫയർ ഇറ്റ് വിൽ കണ്ടക്ട് ഫോർ complete input cycle, or we can say conduction angle will be 360 degree. In class B amplifier, it will conduct through 180 degree of the input signal. Okay. So input signal means we are applying a sinusoidal signal like this, and 180 for the 180 degree of the half cycle of input signal, it will conduct. Okay. And in order to obtain this conduction angle, our Q point should be set at the cutoff point. So this is our cutoff point. Load line, this is our cutoff point. This is our saturation point. Okay. So to the cutoff point, our Q point is set at the cutoff point for class B power amplifier. ഈ പറയുന്ന പോയിന്റ്സ് ഒന്ന് ശ്രദ്ധിക്കണേ. അതായത് ഓരോ ക്ലാസ് ആംപ്ലിഫയേഴ്സ് പഠിക്കുമ്പോഴും നിങ്ങൾ മെയിൻ ആയിട്ട് ഓർക്കേണ്ട പോയിന്റ്സ്, ഒന്ന് അതിന്റെ കണ്ടക്ഷൻ ആംഗിൾ ആണ്, ദെൻ വാട്ട് ഈസ് ദ ക്യൂ പോയിന്റ്, ദെൻ അതിന്റെ എഫിഷ്യൻസി ആണ്. എഫിഷ്യൻസി നമ്മൾ കുറച്ച് കഴിഞ്ഞാൽ പറയും. ഓക്കെ. സോ ഇത്രയും കാര്യങ്ങളാണ് ഒന്ന് മെയിൻ ആയിട്ട് ഓർക്കേണ്ട പോയിന്റ്സ്. സോ in class B power amplifier, it will conduct through 180 degree of the input. Okay. For that, you have to set your Q point at the cutoff point. So, ivideയാണ് Q point select ചെയ്യുന്നത് for class B operation. For class B operation, we are selecting Q point at the cutoff point. That is why 1/2 of the input signal will cut off. നമുക്ക് അല്ലെങ്കിൽ clipped off എന്ന് പറയാം. Okay. അതുകൊണ്ടാണ് ഒരു സിംഗിൾ സൈക്കിൾ മാത്രം ഒപ്റ്റെയിൻ ചെയ്യാൻ പറ്റുന്നത്. Then, ഇതിലും advantages and drawbacks ഉണ്ട്. Now coming to class AB configuration. That is, it is, as the name indicates, it is actually compromise between class A and B. Okay, so we can say it is a compromise between class A and B amplifiers. The conduction angle is between 180 and 360 degree. It will be greater than 180 degree, but less than 360 degree. So, 180 degree class B indadana, 360 degree class A indadana. So, in between that two, this will conduct. Okay, in between class A and B, we can say class AB amplifier will conduct. Okay, so under Q point between the midpoint and cutoff. Midpoint we have 360 degree conduction angle. At the cutoff, you will be 180 degree. So here in between, this our conduction angle will be between 180 degree and 360, means our Q point also in between. Say this is the midpoint, so it will be in between this midpoint and cutoff. Okay. So here we can say if you are applying an input signal like this, okay, our output will be output on the note. So our output will be here 0. Let it be pi and 2π. This is my input signal. That is pi 2π. Okay, this is my input signal, and my output signal will be like this. That is, it is somewhere like this. Okay, so it will conduct more than 180 degree but less than 360 degree. So conduction angle, or we can say the percent of time it will conduct. It will between 180 degree and 360 degree. That is, it is a compromise between class A and class B power amplifiers. So actually നമുക്ക് അതിന്റെ രണ്ടിന്റെയും അഡ്വാൻറ്റേജസ് കുറച്ച് യൂസ് ചെയ്യാൻ പറ്റുന്ന ഒരു കോൺഫിഗറേഷൻ ആണ് ഇത് ക്ലാസ് എ ബി. സ്പെസിഫിക് ആയിട്ട് എടുക്കുമ്പോൾ രണ്ടിലും ഡ്രോബാക്സ് ഉണ്ട്. സോ അതിന്റെ അഡ്വാൻറ്റേജസ് കമ്പൈൻ ചെയ്തിട്ടുള്ള ഒരു കോൺഫിഗറേഷൻ ആണ് ക്ലാസ് എ ബി പവർ ആംപ്ലിഫയർ. So in class AB power amplifier, you have to remember the conduction angle is in between 180 degree and 360 degree. So in order to get that much conduction angle, you have to set the Q point in between midpoint of, in between that you have to fix the Q point such that our conduction angle will be between 180 degree and 360 degree. That is class AB power amplifier. Okay. Then finally coming to class C power amplifier. So നിങ്ങൾക്ക് പഠിക്കാനില്ല, ഡീറ്റെയിൽ ആയിട്ട് പഠിക്കാനില്ല, ബട്ട് ക്ലാസിഫിക്കേഷൻ ഇപ്പോൾ 3 മാർക്സ് ഒക്കെ ചോദിക്കുവാണെങ്കിൽ നിങ്ങൾ ഇതും കൂടെ ഇൻക്ലൂഡ് ചെയ്യണം. ഓക്കെ. So here this amplifier conducts for less than 180 degree of the input. Not the complete half cycle, it will be less than 180 degree of input signal. Okay. So we are applying input signal like this only. Okay. Then less than 180 degree, that is in between 0 and pi. So this will be the conduction angle of class C power amplifier. Okay. So here we are locating our Q point below the cutoff level. Here is the cutoff point. So below the cutoff point, we are setting the Q point. This is the class C operation. But actually, the advantage is actually this will give maximum efficiency. This class C configuration gives maximum efficiency among all these class A, AB, B. While we are considering these all things, this class C power amplifier gives maximum efficiency. Okay. So here for class C configuration, our conduction angle will be less than 180 degree. Okay. For that, Q point is set to below the what cutoff point. Okay. And finally coming to class D amplifier, I'm just mentioning that it is based on digital applications. Class D, class S, different amplifiers for digital application also. So so mainly our classification is class A, class B, class AB, and class C. Okay. So adile conduction angle. Class A and case class A, it is conduction angle is 360 degree. Then class B, it is 180 degree. Class AB, between 180 and 360. And class C, less than 180. This is the conduction angle of each amplifier configuration, power amplifier configuration. So these are the main classification. Then for this, you have to set your Q point for class A operation at the middle of the load line. For class B operation at cutoff point. For class AB, between midpoint of the load line and cutoff point. And for class C, below cutoff point. Okay. So these are the main classification. Also one more thing. നമ്മുടെ സിലബസിൽ സ്പെസിഫൈ ചെയ്യുന്നത് ക്ലാസ് എ, ക്ലാസ് എ ബി ആൻഡ് ക്ലാസ് എ ബി. ഇത്രയാണ് നമുക്ക് പഠിക്കാനുള്ളത്. ഓക്കെ. സോ വി ഹാവ് ടു ഡീൽ വിത്ത് ഇൻ ഡീറ്റെയിൽ വിത്ത് ദിസ് 3 കോൺഫിഗറേഷൻസ്. ബിഫോർ ദാറ്റ്, അതിലേക്ക് പോകുന്നതിന് മുന്നേ ഒരു കാര്യം കൂടെ, പെർഫോമൻസ് പാരാമീറ്റേഴ്സ് ഓഫ് പവർ ആംപ്ലിഫയേഴ്സ്. ഇതാണ് ബെറ്റർ എന്നൊക്കെ പറയുന്നു. ഏതൊക്കെ പെർഫോമൻസ് പാരാമീറ്റേഴ്സ് വെച്ചിട്ടാണ് നമ്മുടെ പവർ ആംപ്ലിഫയേഴ്സ് പെർഫോമൻസ് മെഷർ ചെയ്യുന്നത് അല്ലെങ്കിൽ സ്പെസിഫൈ ചെയ്യുന്നത്. ഓക്കെ. So performance parameters of power amplifier. First one is circuit efficiency, or we can say conversion efficiency. Note here, performance parameters, one important parameter, major parameter is conversion efficiency, or simply we can say efficiency. Okay, that is, it defines the ability of power amplifier to convert DC power supply into AC power output. Okay, and as I already told, a power amplifier draws power from the DC power supply and it gives to the output signal, right? So that conversion efficiency, that DC to AC conversion efficiency, it is actually called as the efficiency of power amplifier. Okay, so the ability of a power amplifier to convert DC power supply into AC power output, that is called conversion efficiency or circuit efficiency. Okay, so it can be defined as max AC output power divided by DC input power. Okay, so represent ചെയ്യുന്നത് efficiency eta is equal to maximum AC output power divided by DC input power. Actually, percentage represent into 100 കൂടെ ചെയ്യും. Okay, so maximum AC output power divided by DC input power. ഓർക്കണം equation ഓർക്കണം efficiency. And this efficiency value depends upon the class of operation. And after class A, class AB, class C. Okay, class C is highest efficiency. Class A will be having lowest efficiency among these classes. Okay, so actually efficiency it varies from 25% to 90%. 100% efficiency is practically impossible. So we can say efficiency varies from 25 to 90%. Okay, so efficiency is equal to, efficiency is the ability of a power amplifier to convert DC power supply into AC power output. That is maximum AC output power divided by DC input power. We are expressing in percentage, so into 100 will give you the efficiency. And the value depends upon the class of operation, class A, B or C, right, like that. And it will be numerically, it will ranges from 25% to 90%. Okay, that is the first performance parameter. And second one is distortion. So we can say a good amplifier output is expected to be enlarged reproduction of input. That means for an amplifier, we can tell, if I am giving a signal like this, okay, I have to amplify the signal, but it should be faithful reproduction. That is, you have to increase the voltage gain, but the shape should be retained. Okay, that shape should be retained at the output. Okay, so this shape should be retained, but the voltage value should be increased. That is the purpose of a good amplifier. Okay, a shape retain cheyano, that is the thing. Okay, but in actual practice, we can say practically there will be a difference in the shape of frequency components. Actually, our voltage amplifier, we are increasing the voltage value only. The shape should be retained like this. That is, frequency components and shape should be retained in a good amplifier. But practically, there will be a difference in shape of frequency components between input and output. So that difference between input and output is called as distortion. Okay, so a signal distorted means there will be a difference in input and output. Difference in the sense, നമ്മുടെ ആംപ്ലിഫയറിന്റെ കേസിൽ ഡിഫറൻസ് ഉണ്ടാവും ഓൾറെഡി. എന്താണ്, എൻലാർജ്ഡ് ആയിരിക്കും, വോൾട്ടേജ് നമ്മൾ ഇൻക്രീസ് ചെയ്യുന്നുണ്ട്. അങ്ങനെയല്ലാതെ അതിന്റെ ഫ്രീക്വൻസിയോ ഷേപ്പിലോ ഉള്ളത്. ഫോർ എക്സാമ്പിൾ, if I am giving an input signal like this and if I am obtaining an output signal like this, this is called as distortion. There will be change in shape, right? Also, there may be frequency variations. Okay, frequency variations like this, we can have the we can have frequency variation, that is frequency increased or decreased, like that. Okay, so if there are any frequency of variation in shape, we can say it is distorted. So the difference between input and output is called distortion in terms of this shape and frequency. Accordingly, you will be having two distortions, harmonic or amplitude distortion. So I will control the shape change, it is harmonic or amplitude distortion. And you will be having crossover distortion. Crossover distortion we'll discuss later. So these are the main type of distortion occurring amplifier circuit. Okay, harmonic or amplitude distortion and crossover distortion. Crossover okay. So there is a distortion, that is the difference between input and output of an amplifier. And the third parameter is power dissipation capability, or we can call it as power rating. Okay, so power dissipation capability is the ability of a power transistor to dissipate heat. So this is one important property, because in power transistor, as already said, it will dissipate more heat, or it will produce more heat. So we have to dissipate that heat without damaging our circuit. We have to dissipate this of metal to the transistor case. That is, if you are connecting a mass of metal to the transistor case, we can say more power can be dissipated through this transistor case. That is why actually our size of power transistor is increasing. Okay, due to this, in order to improve the power dissipation capability, we are connecting a mass of metal to the transistor case. As a result, the size increases, but actually it is required. Otherwise, due to the generated heat, our component will be get damaged. Our circuit will get damaged. So, in order to avoid that, we have to dissipate heat. So, power rating can be improved by connecting a mass metal to the transistor case. Okay. So, these are the basic introduction to this topic. That is, for the power amplifier, we have discussed the classification: class A, class AB, class C, class B. These are the main classification of power amplifier. You have to note the conduction angle and the operating point. Then performance parameters, circuit efficiency, that is conversion efficiency. That is the DC to AC conversion efficiency defines the efficiency of the circuit. Then distortion, then power dissipation capability. These are the main performance parameters of power amplifiers. Okay. Now, first of all, we can see the class A power amplifier. Transformer coupled class A power amplifier എന്ന് സ്പെസിഫൈ ചെയ്ത് പറഞ്ഞിട്ടുണ്ട്. ബട്ട് ട്രാൻസ്ഫോമർ കപ്പിൾഡ് പവർ ആംപ്ലിഫയർ എന്ന് പറയുമ്പോൾ നിങ്ങൾക്ക് ഇനീഷ്യലി അതിന്റെ ഇൻട്രൊഡക്ഷൻ കിട്ടാൻ വേണ്ടി ഞാൻ ജസ്റ്റ് ക്ലാസ് എ പവർ ആംപ്ലിഫയറും കൂടെ ഡിസ്കസ് ചെയ്യാം കേട്ടോ. അത് മനസ്സിലാക്കിയാൽ അവിടെ പിന്നെ ആ ഒരു ട്രാൻസ്ഫോമർ കപ്പിൾഡ് എന്നുള്ള ഡിഫറൻസ് മാത്രമേ നിങ്ങൾ കൂടുതൽ മനസ്സിലാക്കാനുള്ളൂ. സോ ഫസ്റ്റ് വി ക്യാൻ ഡിസ്കസ് ക്ലാസ് എ പവർ ആംപ്ലിഫയർ. ഓക്കെ, സോ ബേസിക്കലി വി ക്യാൻ സേ എ പവർ ആംപ്ലിഫയർ ഇസ് ഓൾസോ എ വോൾട്ടേജ് ആംപ്ലിഫയർ. Basic configuration is similar to our voltage amplifier. Only the difference is that the load resistance connected to the output is relatively low, which result in high current flowing through the collector of the transistor. So this is the major difference. Actually, class A power amplifier എന്ന് പറയുമ്പോഴും നിങ്ങൾ കാണുന്ന സർക്യൂട്ട് it will be our common emitter configuration. Okay, normal circuit will be there. One basic difference is that the load resistance connected. Okay, so you have a load resistor RC. We are connecting to collector terminal. Okay, so this resistance will be high for the case of normal voltage amplifiers. So that the resistance very high anengil, that current flowing IC will be low for the voltage amplifier case. Here, actually, we need power amplification, that is P into V. So we have to get high voltage and high current. So in order to obtain this high current, we are making this connected to the output is relatively low, resulting high current product V into I will be high. So we can obtain high power at the output signal, right? So that is the major difference. And then next one is the transistor. As I already told, transistor used should be having high voltage and power ratings. That is why we are using power transistors. So basically a power amplifier is a voltage amplifier itself, but major difference is that one is load resistance connected will be very low. Okay, in order to obtain high collector current. And second thing is, instead of normal transistor, we have to use transistors with high voltage and power ratings. Okay, high voltage and power ratings. That transistors are called as power transistors. So we are using power transistors here. Okay. So class A amplifier is the simplest form of power amplifier. It actually uses single switching transistor in standard common emitter configuration. Okay, and the transistor is always biased on, so that it conducts during one complete cycle of the input signal waveform. That is, for the class A power amplifier, we already told the conduction angle is 360 degree. So the transistor will be biased like that, it will always on. Or we can say we are fixing the Q point to the middle of the load line. That's why our transistor will be turns on full time. That is, for the complete cycle of input signal waveform, the transistor will be on and it will produce minimum distortion and maximum amplitude at the output signal. Okay, so transistor is always on and it conducts for one complete full cycle of input signal waveform and produces minimum distortion and maximum amplitude of the output signal. Okay. This is the actual class A power amplifier. So, this is simply our common emitter configuration. We have this RE and CE, emitter resistance and bypass capacitors here, and this R1 and R2 biasing resistors. In order to fix our Q point to the middle of the load line, we are biasing. So, biasing resistors are R1 and R2. Okay, and we are applying input signal to the base. And here, actually, this is the difference, this load resistance. This will be very less value, very low value. Okay, so also this transistor, this will not be our normal BJTs, that is normal BC107, it will be a power transistor. That is the only difference. So circuit arrangement will be same as our voltage amplifier. Okay. So നമുക്ക് ഇതിന്റെ ഡീറ്റെയിൽ ആയിട്ടുള്ള കാര്യങ്ങൾ നെക്സ്റ്റ് ക്ലാസ് ഡിസ്കസ് ചെയ്യാം. ഇന്നിവിടെ സ്റ്റോപ്പ് ചെയ്യാണ്. ഇത്രയും പറഞ്ഞ ഇൻട്രൊഡക്ഷൻ ക്ലിയർ ആണോ? ഇൻട്രൊഡക്ഷൻ പറഞ്ഞ കാര്യങ്ങൾ ക്ലിയർ ആണോ പവർ ആംപ്ലിഫയേഴ്സിന്റെ കേസിൽ? എന്താ അക്ഷയ്